All right, and I think we are good to go. So, hello everybody, thanks for tuning in. We are looking at 1588 today, which is talking specifically about Chrono's system clock now and file clock and LeapSeconds, which is everyone's favorite topic. Statement Reply has had this open for a little bit now and gotten some input from other contributors as well as Billy, specifically around a lot of the concurrency and file time stuff, since he has a lot of experience in those areas of the code base / wrote them. So I think that we have some really good content to talk about today. This is a draft PR, and kind of looking through the changes that I saw in the actual files here. Some of them are doing what looks like some setup, some is actually making product code changes. I don't know that we are in a place where at this point this is something that is like close to being completely mergeable, but I think that this is still some good stuff to definitely talk about and explore and get input on from all of you. So just to kind of set expectations, this is not necessarily going to be completely polished and ready to go, but I think Statement Reply, part of the intent here is to put some ideas out there and make sure that we're kind of in agreement on the general approach to take and what we want to actually do, because in this particular case, unfortunately, it is a little bit difficult to be completely standards conformant. So there is a little bit of a question of how we are going to handle these different cases and what we're going to be kind of doing to get as close as possible, or what we are going to maybe have to fudge a little bit. So to get into a little bit of the background here, we're talking about system clock. We're kind of referencing UTC clock, and we're also talking about file clock. So I wanted to start in the standard, not there. Sorry, I very rarely use my bookmarks, and of course this is when I accidentally click it. So if we go to standard and go to the time library, I didn't actually check. Is this the most recent working draft stuff in 4878, or is it 4885 now?
There's an even newer one now. That FSB 4000 created a PR to update our README 2. I want to say it's 4892. I haven't yet completely memorized the number.
4892. Is it? Do you know if that PR went through?
No, it hasn't been merged yet. It's part of the big merge batch, but it is like the most recent PR. That actually might be the fastest way to find it. In theory, going to wg21.link/std would get you the latest.
I did to get here, yeah.
Yeah, that one is manually updated, and it's not always the very latest. Oh yeah, there it is, 4892.
4892, okay, great. Just changing this should get me there, right?
Nope. No, it's 2021. The year in the URL.
Oh, that's super obvious. Thank you. Nope.
Oh yeah, this one is actually currently hosted on isocpp.org. So you'll need to use wg21.link/n4892, and that'll get you the right URL.
There we go. Okay, thank you. For those of you who didn't know how to find different standards versions, this was all done purposely for your education. Okay, so looking in the time library here, I'm going to zoom in a bit for everyone to be able to see. If we go and look under clocks, we'll see we have a lot of different clocks. Actually, I'll start in general here. We have SystemClock. We have different members and non-members of SystemClock. We also have UTC clock. We also have tie clock and GPS clock and file clock, as well as steady clock and high resolution. We have lots of stuff going on. The main thing is to kind of know for this particular PR is that system clock is generally supposed to represent time since the epoch, 1971 UTC, but this is specifically supposed to be excluding leap seconds. So now that we are, as you may have noticed, talking about leap seconds here and how to handle leap seconds correctly, that is definitely something we want to keep in mind in terms of system clock. So system clock, leap second agnostic, as opposed to UTC clock, which should be including leap seconds. So using the same epoch, but we should be including leap seconds for UTC clock. Okay, and then finally, the last thing that we're kind of talking about in terms of clocks here is file clock. And file clock is a little bit interesting. And it is specifically because it is a little bit up to the implementers on what exactly we want to do with file clock here. So you'll kind of see under member functions even, the type noted by file clock provides precisely one of the following two sets of static member functions. We can either do to and from sys, or we can do to and from UTC. It's kind of up to us and what is implementable on our platform. So file clock is something that we have a little bit more say in, and that is going to be good given the kind of fudginess that we have to deal with to do LeapSeconds adequately or correctly / okayly. Cool. Mark Goodner has a question. What's the longest movie that is out this weekend? I don't know. Are you measuring with SystemClock or file clock or UTC clock? That's a very poor way to try to tie that question back to the subject at hand. But here we are. Okay, I have like notes for some of the things that I wanted to talk about. Okay, so one question is like, okay, if we have these things already set up, we know what they're all supposed to do. What is the big deal? So basically, the big deal is that Windows 10 / Windows Server 2019 decided to kind of change the game a little bit, and they have started supporting LeapSeconds and counting them in the OS. Okay, so specifically, LeapSeconds that are after July 2018 are going to be included in the tick count of file time. Funnily enough, there haven't been any LeapSeconds since July 2018, but the point is when they start to happen, we're going to have to handle that case. So that's what we have to kind of think carefully about dealing with now. So I'll drop these links in the chat for those who are interested, but these are kind of the two main documentation resources, blog posts that we have been using to kind of fully flesh out what this means and how it affects what we're doing here. But specifically, whenever we deal with file time now in the STL, we're going to have to keep in mind that depending on what version of the OS we're dealing with and whether you decide to enable LeapSeconds, file time could be including LeapSeconds in that tick count, or it could not be, because even if you have a version of Windows that can support LeapSeconds, you can turn that off. So this PR is attempting to kind of handle that, detect whether LeapSeconds are being counted by the OS, and react accordingly. Are there any questions so far? Okay. So check out the blog post if you're interested. There's a lot of stuff in here. I'll probably be searching around in there a little bit just to refresh on what everything is saying and kind of the specifics. But yeah, the main thing that we're kind of going to have to be dealing with the OS changes is this file time struct, as well as the Windows API functions like file time to system time to file time, to interpret that file time information. Okay, so I think it was this one here that actually starts talking about file time. So if you're not familiar, file time is a structure that just records a timestamp. There are historical reasons it is called file time, but it really just represents a timestamp in general. And specifically, it represents the number of 100 nanosecond intervals since January 1st, 1601. Which is a little bit interesting, but this is kind of the epoch for file clock, essentially what ends up happening. So there are a lot of APIs available to convert this into a more readable form. One of them is file time to system time, which statement reply references. But this converts file time into system time, representing the UTC time of that value. Okay, so here's where things get a little bit more interesting. So beginning in this update, the time APIs, and if I open this up, you can kind of see what kinds of APIs are being listed here. They are now going to take into account all LeapSeconds the operating system is aware of when it translates file time to system time. So no change is actually made to file time itself, but the interpretation of file time seems to change here when you are working with these specific these affected APIs. So this is interesting. And specifically, yeah, down here, system time before had valid values 0 and 59 for seconds, but now it's going to allow for a value of 60, which is where we are actually inserting a leap second to kind of indicate that. Whereas I think before it would insert like half leap seconds sometime, like if you moved to that time, it would be like 59, 59.5, and then 0, 0, 0 after the next kind of tick. But regardless, this is something we have to be thinking about now. Okay, and file time we use in SystemClock now, kind of indirectly. We also kind of use it in the file clock conversions. These I didn't see a lot of changes to in the actual PR yet, so I think that they are a bit more work in progress. Again, trying to get a feel for whether this general idea is agreed upon before jumping in on all of that work. And 2xtime 10-day clamp, which calls SystemClock now. So file time is kind of weaving its way around in a lot of different areas, and we're going to have to kind of take a look and make sure that things are interacting with it correctly now that we have to think about leap seconds in some cases. Yeah. Okay, another very fun aspect that we have to be thinking about here, where we got a lot of input from Billy actually, is that this PR could potentially break an already somewhat broken timed wait ABI, because this 10-day clamped function is used by some of our concurrency machinery, such as condition variable, wait for, and sleep for. And if we have some potential ABI concerns where if we have kind of the old version of 2xtime 10-day clamped linked with some of our newer changes to maybe SystemClock now, and that old version of 2xtime 10-day clamped calls SystemClock now, we could be off by some number of seconds here. So this is something we also have to think about. I think that the general consensus that was come to after some discussion with Billy in our Discord here, which I know that the text here is pretty difficult to see, but if you're on our Discord and want to go look it up, it's one of the more recent discussions in the Chrono channel, was that essentially we think that it is worth it because otherwise we're going to have some pretty non-conformant code according to this standard. And also this stuff is already a little bit, yeah, as it says, already somewhat broken. So we think that it's going to be worth it, but it is something we have to think about, and there's been a lot of discussion about it. Okay, any questions before we start looking at the files changed? I am not the most expert on all of this stuff, so if I explain something or glossed over something, let me know and I'll do my best.
With the article that you linked, I think it was the second one. Yeah, this one. I was wondering, should the change that Windows has made, should that be thought of as changing the meaning of file time, or changing the meaning of their system time structure, or just the conversion? And also, I noticed the naming between, like in the standard, system clock means classic Unix time, no leap seconds. UTC clock means do consider leap seconds.
Yeah.
If the interpretation of system time is changing, do we need to constantly keep that potential difference between its naming of system and then the system clock in our minds to avoid confusion? I'm like a little uncertain there.
Yeah, from my understanding, essentially, so the APIs here mean that we are going to be having a different interpretation of the system time, like all caps system time structure. Specifically, we have to be able to potentially handle a value of 60 in the seconds field. I think that we are going to have to be dealing with this kind of two different notions of what a system time or system clock is. One of the more significant product code changes in the PR here is actually, let me just minimize and then just open up chrono, is actually to SystemClock's now function. And it's still going to be kind of using xtimeh get ticks, which goes and talks to file time and uses those Windows APIs. But there's a lot more work done here to kind of try to appropriately account for things. So you can even see if our UTC second is less than 60, do this thing. Otherwise, we're in a positive leap second. We're going to do this other thing. So I haven't gone through all of this code yet to actually see all of the math that's happening. But this is what the previous code was, which was very, very simple and pretty much just rewrapping the information we get back from the Windows API in a particular way. And we're not going to be able to do that quite as easily anymore. So that's the idea. I forget what your other question was.
I think that answers it. It was just like which types have their interpretation changing.
Yeah.
And the answer is, okay, well, the system time could have two possible interpretations depending on the runtime. So we just need to be very careful whenever we map. And you've pointed to the code that does that, so that looks good.
Yeah, definitely. Something that I am still a little bit fuzzy on, and maybe I have reached out to Dan Cuomo, who is the author of this particular blog post, for some other LeapSecond questions. But maybe the team that he pointed to, or maybe himself, can help with this, is specifically, so no change is made to file time. It's just the interpretation of file time that changes. So it seems like in these APIs itself, it does the work to kind of detect, should we be during a positive leap second or not? But we also have this notion that these time APIs, so these ones that are being affected here, are going to take into account all leap seconds that the operating system is aware of, which to me sounds like leap seconds since 2018, which is, I think, what statement reply explains in the description here. So that is what that's how I am interpreting it. But there's also, oh Lord, it's in here somewhere. Very somewhere in here, maybe someone who is not presenting / showing their screen right now can search around in the files. There was a note in one of these particular blog posts that was saying that, oh, so if we were previously not paying attention to leap seconds, what was happening? Like, were we just 22 leap seconds off if like 22 leap seconds had theoretically occurred, or what was going on? And it did say that basically the next time that the OS tried to like sync up and make sure that like, okay, everything is like lined up with where it's supposed to be, it would notice, oh, I'm a second behind, and I'll just sync up and kind of jump forward a little bit. So it does kind of end up including that leap second, even if it's not like literally counting it and ticking forward through it. So there's a few things in there that I'm a little bit hazy on still, and exactly how that factors into this. It sounds like that maybe doesn't factor into specifically file time and that tick, but it's just through maybe the display or some other logic in the OS. But those are some things that I think we need to also be thinking about carefully. Are there any other questions? Okay. On that note, I think I will look at some of the code that's going on here. I will note a few things that happened just through the PR. This has been sitting for a little while just because we've had other things that we've had to prioritize above it, but we thank everyone for their patience. Matt Stephenson, who actually went and implemented a lot of the C++20 LeapSecond work, kind of chimed in here saying that, you know, his approach was similar in a lot of ways. He did end up going to the registry to get the LeapSecond information, the registry that is mentioned in Dan Cuomo's blog post here. For conversions in between, better to delegate this to the OS when possible. Did end up adding a new function, and that, I think that was okay. We ended up keeping that. I think these questions were things that were in the PR's description before editing to kind of update with more information, but talking about whether we should try to, because we have this issue where we have like system clock versus the file clock, and sometimes LeapSeconds are counted and sometimes not, how to deal with it. I think that we are trying to focus on making system clock now correct, because that's very nicely defined, whereas file clock and file time are a little bit hazier. As we kind of saw, it's up to the implementers to have a little bit more say on what happens there. We also had input from Billy, things about what to kind of prioritize here in terms of not messing with existing things, xtimeh get, fixed offsets from file time. And we did have a brief review from Stefan looking specifically at some of the import lib stuff, which we'll take a look at again, but is much appreciated because that's an area that I'm not quite as confident in knowing all the pieces of. Okay. All that being said, let's come over to files changed. All right, so first thing is CMake lists. So if we minimize everything, we are adding 2 new files. We have a header file and a source file here. So these are just being added. It looks like this is, I'm not going to actually go all the way up here, but this is like a headers list. And otherwise, it looks like this is in alphabetical order, because I think numbers come before letters. And then we have the source file listed as well, and again, alphabetical. So that seems good. Okay, let's look at chrono. So we are including a new header. That header has a lot of the interesting stuff, so it makes sense to include it because we're going to be using it presumably here. So we're in the clocks region. We're in a if has CXX20 region, maybe. But we're right above system clock, and it looks like, I know that this function already existed before these changes, so I think it's being lifted out from somewhere. Days from civil. Yeah, so I think previously this was inside of something. This is inside of year, month, day stuff. I think it might have been a helper function inside of one of the calendrical types, but it looks like we're going to end up using it for system clock, so that's just being lifted out, and we are calling it there instead. So that seems fine enough. I should probably take a note from Stefan's typical toolbox and actually pay attention to what is happening here, and make sure that everything looks okay. So let me just open up Notepad, and I'm going to paste in some of the stuff that's happening. Oh, Notepad is not smart enough to shift tab. That's unfortunate. I'm just going to leave it. This is very small, so let's make it bigger. And let's come back up here to see what is actually changing. Okay. So notice card, const expert, days from civil. We are citing Howard Hinnant here because we are using or at least using as inspiration or a basis, some of his algorithms that he's published for kind of free use. So we'll want to make sure that we are appropriately referencing year, month, and day. This is the same digits, at least 18. Looks like we're adding a message here. Seems fine. Static assert equal to 26. And then otherwise, oops, sorry. Looks like we are not taking month and year as actual those actual calendrical types anymore. We are taking them as unsigned int, so we don't have to have this kind of static cast extra work, which is nice. This seems unnecessary now because we're taking it as an int. Make this a suggestion. since this is now being taken as a int parameter, achieve I will start a review, package up all of my review comments nicely to be submitted at the same time. Okay. Now we have a big comment in the middle. I can't like hide it. That's annoying. Okay. Const int century. So Mo is now just month because again, that is already an unsigned int. So that seems fine. I can't, at one point I did try to look through the formulas here in the math and at least make sure that it lined up with the algorithm that Howard listed to make sure that it was somewhat sensical. I cannot walk through all of that math right now, but I have pretty decent confidence in it. Plus, statement reply is a bit of a math whiz, at least in my experience. So, yeah, and again, day is I think already an unsigned int. Yeah, so we don't need that cast. -1. Great. And here we are not creating a days from it because we're probably just, yeah, returning it as an int instead. That seems good. Okay. I am pretty happy with that. I am wondering if, oh, okay, great. So actually statement reply, I think did come in here and kind of optimize some of the algorithms here and fancy math involved. And the math was a little bit over my head, so I actually asked for some clarification and comments, like, can you explain what's going on here? And they added some beautiful comments, but the formulas 1 and 2 that are being referenced here are explained in that comment. And I was just about to say, hey, we're moving this up, but what about those comments, those beautiful comments? And they actually have already gone ahead and said where to go and find them. So I think that is totally fine with me. I don't feel the need to replicate these massively beautiful comments. I think that's good. Okay, cool. That seems fine. All right, now we are inside of SystemClock itself. And yes, some of the changes that are being done to the now member function. So previously, xtimeh get ticks was just being basically wrapped in a duration, then a time point, and being returned. We can actually go and look at what xtimeh get ticks looks like. I had to go and do this a little bit before. It's an xtimeh.cpp. So here, this is get system time in 100 nanosecond intervals since the epoch. So we are basically using file time to get system time and then returning it, accounting for the epoch, which, as I recall, this is a fancy way to say the actual file time epoch. Or at least there's a long hex string that elsewhere in the STL that claims to be what that is. Yeah, Stefan?
Yeah, I believe that's the offset in 100 nanosecond chunks between the 1970 and 1601 epochs.
Right.
I think there might be another, like you mentioned, an explicit derivation of that magic value elsewhere. And here it's just repeated.
Right, okay. Is this the same one or is this different? This I'm pretty sure is the same one. You know, we could check this. Yes, is the same one. Okay, cool. So this is directly talking to file time, which makes little alarms go off in our heads for this particular PR. Get system time precise as file time. I don't know is actually listed here. I don't see it, though it is on this page elsewhere. So I guess maybe that is another question. I would imagine that it is also included here because we're dealing with system times and file times, but I don't actually know that for sure. Okay, maybe a question. I may come back and edit this wording or figure out how exactly to redirect it. But maybe where do we actually call xtime get ticks? Just to either make a note to myself to come back and look into this more because I'm a little bit hazy on whether this specific API is affected or not, slash at least maybe statement reply has more insight into it. Note, I am unsure whether, let's see, the exact call that happens here. I guess I will include both of these lines. I'm unsure whether xtime get ticks is, or I'm unsure, I guess maybe how xtime get ticks is affected by the LeapSeconds related changes in the OS versions. Poorly worded sentence, but I can come back and clarify later. Specifically, this function contains I assume that CRT get system time precises file time wraps get system time precises file time, the actual Windows API.
That's right. The reason why it's a wrapper, not directly calling, is because the precise version, which uses query performance counter to provide very high resolution, was only added in Windows 8. So if at runtime we detect, oh, the user system is Win 7 or older, we fall back to the coarse-grained get system time as file time without the precise bit.
Interesting. That's very cool.
Yeah, if we had Win 8 or higher, like Win 10 as our minimum supported OS, which might happen in 30 years, then we could unconditionally call the precise version. We actually did hear some reports that apparently the precise call to query performance counter has performance effects on certain virtual machines, where if you ask for the precise version, it has to do hypervisor magic, and it can be really slow. So perhaps it wasn't actually a good idea to call the precise version. But since we've got this in our separately compiled code, we haven't changed that.
Interesting. Thank you. Okay. Yeah, I actually did not know all the background there. Unsure of how this is affected by LeapSeconds related changes in the OS version, specifically this function contains this, where CRT get system time. Mother. I'm going to try not to swear. Get system time as file time, or this is annoying to type out. And neither of these functions is listed on as an affected API. I will link this. I'm verifying that I am saying true things. Yes, the only two get things are not the same. On this. It makes sense to me that they would be affected, but I just want to double check / ask for some clarity here. Okay. Note, I am unsure of how xtime get ticks is affected. is affected by the LeapSeconds related changes in the different OS versions. Specifically, this function contains these lines where this line wraps either get system time as file time or it gets system time precise as file time. And neither of these functions is listed as an affected API on this blog. It would make sense to me that they would be affected, but I just want to double check / ask for some clarity here. Maybe not the super uber clearest, but it seems decent enough, I will say, in different OS versions and in this blog. Okay. Charlie is surprised by hypervisor slowdowns. And Billy is chiming in too. Great. Okay. So looking at this, we have this FS file time epic adjustment, which we got a little background on from Stefan. Thank you. So we're keeping track of this. I do note that this is showing up now in 2 places in this file. I don't know if we care enough to lift it out anywhere. I think it is also showing up in probably FileClock. It's only showing up 2 times as far as I know, as well as I guess in the source file. But something to be aware of, I guess. This is a long, somewhat obscure hex string that seems potentially easily muddled. But yeah. All right, creating a file time using getTicks and adjusting by the file time epic adjustment. So again, this is adjusting between the file clock, like the struct file time epic, and the system clock epic 1601 to 1970, but in the count of 100 nanosecond intervals, it sounds like. So that seems reasonable to me.
Regarding the constant, I think you have an excellent observation that it's now being repeated. And I can't remember exactly why we didn't centralize it before. I think we didn't really have both the repetition and a good place to centralize it. But now, in this PR, statement reply is introducing that xtimeh.h, which I believe is extremely lightweight. So I think it could actually be moved there.
Oh, okay, great. Well, I'll make a comment on this, and once we get to xtimeh.h, we can reevaluate potentially. But yeah, that makes sense to me as well. It looks like this same value is being repeated in this file. I guess I can actually find out where it is being repeated now. Do I still have it copied? Oh no, here it is. Okay, in file system. So it's showing up 1 time in file system right now. But now we're going to be making it 2 times. In file system, is it in file system itself? Yeah, the namespace file system right outside of file time clock. I'm going to say in namespace file system by file clock things, as well as here and in CP. Previously, we didn't have a great place to centralize this constant, or I guess maybe to put this constant to avoid repetition, hence potential for typos in this long obscure hex string. But now that you're adding x times 0.h, I think it, or I should really say, Stefan thinks it could potentially live there instead. Looks like the same value is being repeated in this file, there as well as here. I feel like my parentheses need some work here, but that's okay. Previously, we didn't have a great place to put this constant to avoid repetition, and hence this potential. Now that you're adding xtime. All right, I think I'm satisfied with that. I can come back and maybe clarify things a little bit more at a later date. Probably this date, but later today. Okay. All right, creating a file time duration, again, using the ticks from file time in those 100 nanosecond intervals, accounting for the adjustment. And then we say, let's chrono duration cast this to seconds and store that in file seconds. Okay, and we're using nice auto in conjunction with a kind of cast, since it's explicit what the type is going to be. Okay. Right, std UTC components 1s. I am not familiar with this. I am wondering if this is something that is in the added header. Stefan seems to know, which means I don't think that he is familiar with this either. Let me come down here and see maybe what's going on. Yes, so struct std UTC components 1s. So we have year, month, day, weekday, hour, minute, second. So this other struct that is being added has kind of a reference of what it is, what it corresponds to, the actual like SystemTime struct. I'm not sure what this exactly corresponds to. Maybe I can see how it's used in this file. Components. Converts UTC whole seconds into file time seconds. Converting file time seconds into UTC, so out, okay. So it's representing whole seconds in UTC versus file time's notion of seconds. Interesting. Wonder if there's more context in here. Converting whole, yeah, this is UTC time. Oh boy, another beautifully formatted comment with nice tables. Where was UTC time being actually used here? Oh, it's actually it's populating all of the SystemTime struct. Okay, so it sounds like it is essentially trying to represent a SystemTime, but in UTC. So it's going to contain all of the equivalent information, but not including milliseconds. We had that comment up here that's talking about whole seconds. Okay. I guess we'll come back to that, but let's see how it's actually being used in chrono. I think we are up here. Okay, so create this struct that has all of those fields to keep track of a duration of time or period in time. All right, std file time to UTC errc. You see, so some kind of error code being returned from a file seconds to UTC components call. Again, this double underscore std. I think we conventionally have be calls to a the header source files that we were kind of referencing before. And here we're getting the count of file seconds passing in and then giving it the address of the UTC struct that we can have be populated with the translated information, it sounds like. Okay, and then we want to STL internal check that this actually worked. Stefan, can you remind me of, so I know there's STL internal checks, I know there's STL verifies, I know there's static asserts. What the differences are here and what this actually does if this fails?
So the internal ones are active only for our test suite, and they just completely vanish for user code. So we use them when we're highly confident that they should always pass, but if they do fail, we want to see them in our test code, but we expect they will never fail due to like runtime conditions.
Okay.
We use them only when they would detect like egregious programming errors, like we forgot an adjustment or we threw an exception when we totally shouldn't have.
Okay.
And that applies to both the STL internal check, which is a runtime check that I believe triggers an assertion and then terminates the program, and STL internal static assert, which expands to a static assert for the test. The ones without internal, which are like STL, assert, and verify, those are runtime checks. The difference there is that an STL verify always executes, even in release mode. And an STL, STL assert will be erased if we are in release mode. The preprocess is away. Following the usual conventions around assert versus verify. Oftentimes we will have a verify, but it'll be if-def by other things. And that's why we use that. And then for static certs that should be emitted to the user, we just say literal static cert. There's
Sure.
in product code no reason to cloak that in a macro.
Yeah, I think the most common places I see like in plain static assert is in like sometimes preconditioned stuff. Okay.
That's right. Anytime that the standard says that, it used to be, it had some strange wording around shall be ill-formed, and thankfully a bunch of committee members did excruciatingly repetitive work to make the standard a lot clearer. It's greatly appreciated, where now there's a specific, what they call an element that appears in italic text. And if it says, I believe mandates, something like mandates, the animal is cute and fluffy, that means that if it's not cute and fluffy, we need to not compile the program, and so that must be enforced with a static cert, whereas other things can trigger undefined behavior, so they don't need to be diagnosed, but an implementation can if they want.
Gotcha. Okay, that makes sense. And I think that we don't really expect this to fail for any kind of fleeting reason. So I think an STL internal check makes sense here. And then other error handling, if what we get back is an invalid parameter, we're going to, okay, let's see. Return a time point that is the file time, which is again the duration, the xtime get ticks plus the epoch adjustment, but subtract off the epoch adjustment. So that would mean that we are just returning the plain count of 100 nanosecond intervals from before, which actually I think is essentially what this code was previously doing, right? Call xtime get ticks, make a duration of it, which is what's happening kind of here, except we're adding on and then we end up subtracting away, but we're turning it as a time point. Okay, so it seems like this is essentially the old behavior. Okay, I think on that a little bit more. Okay. We have using days using int seconds. Okay. So ratio 86,400. I remember seeing 86,400 somewhere in here. One day, 86,400, I believe, seconds in a day. Someone can do quick math if they want to. Oh wait, it just literally says nice of how many seconds that day has. Okay, so that number makes sense at least. Duration, days, and then this ratio. I think that, okay, now I have to, maybe I will actually go and go through the process to actually remember the different template parameters for durations. I like to look at CPP reference sometimes when I don't know exactly where something exists in the standard. It hasn't bitten me yet. Rep and period, which is going to be some kind of stood ratio. And period is representing the tick period, i.e. number of seconds per tick. So here our tick is going to be days, it sounds like, and we're going to have 86,400 seconds per tick or per day, right? This seems to make sense here, and int seems fine to me. Then using int seconds as chrono duration int, and then the ratio default is ratio of 1, which I think is over here. Yeah. So it's counting seconds. Makes sense that it would just be ratio 1. Okay. constellation YMD days from civil. Again, that's lifted out. So we're saying given this year, month, and day, give me the actual number of days. Can actually come back up and remember. Yeah, conversions between the dates in the proleptic Gregorian calendar and the continuous count of days since that 1970 epoch. So we're taking the civil year and month and day and then getting just the count of days back there. And then we're just creating a chrono duration days, putting that here. Then we're getting HMS, which is the hours, minutes, and seconds, again, just from that populated UTC struct. And storing that. Okay, cool, seems good. Okay, so here we have the actual handling of, are we in a leap second or not? If our second is less than 60, we are going to return a time point with the year, month, day, plus the HMS, and then plus file time minus file seconds. Okay, let me remember what these are. File seconds was the duration cast of seconds from file time. And file time was the actual adjusted get ticks. So what is this going to actually do here? So file time, I think, could potentially have milliseconds. So for duration casting to seconds, we're like, something has to be changing between this and this in order for this line to make sense. And this has to actually have a reason for occurring. So let me see. Xtime get ticks, I think that was here. So we're returning this as a long, but we are get system time in 100 nanosecond intervals. Okay. Maybe looking at get system time, file time / precises file time would be helpful to me here, because I'm just not as familiar with those specific calls. Choose the current system date and time at the highest possible level of precision. Coordinated universal time, UTC. Okay. So I assume that it populates the given file time struct with that information. Or that is not what this sounds like.
It's definitely an out parameter. The documentation is somewhat confusingly phrased because it contains the system date and time in UTC format after the function is done.
Okay, that's what I was assuming was maybe happening here. I'm glad that I'm not just misreading it or something. Okay. I will make a paper note that maybe someone should fix that documentation. Okay, cool, thank you. Okay, so this is potentially going to have a much more specific level of precision than just seconds. So yeah, it sounds like we're trying to deal with the potential fraction that's being lost when we do the duration cast to seconds. So that makes sense. And again, I think is file time in here? No, not easily.
You can click on the type in the parameters. That's a hyperlink.
Thank
It's
you.
also worth noting that the non-precise function, although it is less precise, it still returns values with approximately like 15 millisecond granularity. So
Okay.
definitely some.
Okay, great. That makes sense then. Awesome. Thank you. Oh yeah, and I was seeing that these were being referenced in xtimeh in that return statement. These two members of the struct. So cool. Low order part of the file time and high order part of the file time. That sounds complicated. Okay, thank you for the background stuff, and I'm a little bit more clear on what's going on here then. Okay, so here, then we're going, if we are not in a leap second, then let's try to actually account for the fractional seconds that are happening here. Otherwise, if we are in a positive leap second, we are going to subtract off a second because SystemClock now should not be dealing with actual leap seconds in C++ standard SystemClock, not SystemTime according to Windows. Okay. I think this makes sense to me. The other really fun part of this is, yeah, we can't easily test this because there have been no leap seconds since this update. And none planned as far as I know of, or as far as Wikipedia knows, as of yet, but okay. I'm just looking in the chat. Okay, cool. Something that I am thinking of, and maybe it does not need to be handled here, but I did not see it actually mentioned in the other blog posts, is negative leap seconds, because negative leap seconds are a thing. I think we have had one in our history, and the fact that we are specifically saying positive here, I'm wondering if we are thinking about whether / how to handle negative leap seconds.
I believe a negative leap second has never actually occurred, although it is a theoretical possibility.
Okay.
Which makes it even
that
harder
sounds
because
right.
there's no historical things that we can test for.
Yeah. I just remember there was a whole little section on Wikipedia about negative leap seconds. Yeah. Negative leap second would suppress, oh, this is very small, apologies. Negative leap second would suppress second 235959 of the last day of a chosen month so that the second 235958 of that date would be followed immediately by 000, all the zeros. Since the introduction of leap seconds, the mean solar day has outpaced atomic time only for very brief periods and has not triggered a negative leap second yet. Here's the table of actually all the leap seconds that have occurred since 1972 when they started being a thing. And you see there's only +1s, no negative ones. And we do not yet know whether we will have another one this year in December. Anyway, I'll probably comment on it just for the sake of, let's keep this in mind. I don't know how that would be noticed / represented in the Windows API that we're using, because I don't think it was actually referenced in here anywhere. No negative. No negative. Okay. Yeah, I'll comment on it and see if anyone else has more context maybe for what that would look like. And we can maybe at least look into it or file maybe an issue to come back and look again in a little while and just see what's going on. The comment, positive leap second, maybe wonder how / whether we need to handle potential future negative. Let's see. Negative leap seconds referenced in either, I like whenever possible to link what I'm, nope, don't do that. I clicked a Teams thing. I like whenever possible to try to link what I'm talking about because it's very clear to me, but especially me coming back months from now or someone else may not be clear.
I think you toggled your teams to present your screen and your video side by side, so now the screen is really small. You might want to hover over the thing.
Does this work?
Yeah, now you're back to the screen.
Okay, cool. Thank you. I did actually click on something, but then I exited out the window that came up, so I thought maybe I canceled it. But thank you.
Sorry for interrupting.
No, it's okay. The YouTube video is gonna be going wow, 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 wow. Okay, Dan's blog post. Either Dan's or I forget who actually wrote this one. Daniel Havey. No, don't click it again. This is why maximized browser windows when you're trying to screen share are really bad. Wait, so we have a Dan and a Daniel. That's fun. Whatever. I'm wondering if there is any documentation for how a negative leap second would be represented in the Windows APIs // Okay. Lots of questions, not really anything to super change so far, but at least thinking critically about what's going on here. Okay, I am thinking again about this line, and I'm guessing that it's just sort of like when would we get an invalid parameter? Stood file time to UTC IRC. This would be one of the new, I think one of the new things. So here's the class. We're in the header, so let me actually go down to the source file. Stood file seconds to UTC components. Using this. Okay, so when file time to system time gives us back false. So let's see when that actually happens. Ooh, it was probably in here though. Nope.
I think if you do type your search into that left-hand box, like that. But you can, that filter by title, there's like a link to search in like all Windows API documentation that usually gets you where you want to go.
Thank you. Okay, this is the call, converts the file time to a system time format. System time is UTC. These are the parameters. Return value, if the function succeeds, the return value is non-zero. Okay, that is super helpful. So if the function fails, return value is 0 or false, as we are checking for here. Okay, so if it just fails for whatever reason, I guess we say invalid parameter. I wonder what are the other things that this can be. Oh no, it's all the way up in the header. Okay, success, invalid parameter. Non-existent. Okay, interesting. Oh, and then we get into LeapSeconds smearing, which is weird too. Okay, so it seems like invalid parameter is essentially just it fails for some reason. The input is invalid regardless of whether there are LeapSeconds. Okay, that seems fine. I don't know that invalid parameter makes the most sense to me as a name, because it seems like it's not necessarily one of the parameters we gave it as invalid, or maybe that's the only reason it can fail. It just doesn't seem to be incredibly clear from the documentation, but I don't have a huge problem with it. Okay, so it seems like if we have an invalid parameter, let's just do what we were doing before and not try to handle any LeapSeconds, because we can't access that information anyway. So I think that seems reasonable to me. Okay, cool.
And the STL internal check above makes it clear that statement reply really expects this API to always succeed. So I think the technique is extremely defensive, which is good.
Yeah.
In case that, you know, far future version of Windows fails here for some unknown reason.
Yeah. Yes, statement reply is historically very, very thorough, which is much appreciated. Here's this beautiful comment explaining the math that's going on here. Okay, so we removed this comment because that's being moved up because we moved this function essentially, and now we're just calling that function. That seems good. Okay, so here we're in a helpers section, and we have some kind of renaming / making a v2, and the v2s, as I understand it, are almost always related to ABI scariness. So to xtime 10-day clamped. This is converting duration to xtime. Max 10 days from now returns whether clamping occurred. If clamped, timeouts will be transformed into spurious non-timeout weeks due to ABI restrictions where the other side of the DLL boundary overflows in 32 milliseconds. This is a lot in this sentence, but as we may recall, this was one of the functions that uses SystemClock now, but now that we are changing what SystemClock now means, we have to be more cognizant of the ABI implications from that. So what it looks like to me is we are actually preserving to xtime 10-day clamped as a function, period. But instead of having all the guts here, we're calling this to xtime 10-day clamped v2. Where this has the same guts, but instead of doing now paren time since epoch, which it was before, we are actually basically replicating what now used to be, where we were just creating a time point and duration of xtime get ticks. And xtime get ticks implementation, I believe, is not changing. So this is preserving the old behavior and not being updated along with SystemClock now, because I think that we're trying to not break things. I think everything else here is staying the same. And this is, yeah, this is the same that it was before. Same parameters and everything. Okay, so thinking ABI wise, and Stefan, jump in and correct me if I say anything that does not seem right. The situation that I think we are considering are linking different versions of basically these sources. So, or this header. So if we have an old version of 10-day clamped, it'll just do all this guts stuff anyway. But couldn't we still have the old version called SystemClock now? Where if we have this new version, we're going through and doing basically replicating the old behavior. But I guess I'm not completely clear on why this is helping us. I know a v2 is a fancy, helpful thing to kind of sidestep some ABI things, but I'm not sure exactly how this part factors in.
Yeah, I think you found an issue here. So the idea behind renaming is that the linker, as far as the linker is concerned, renames don't really exist. It's just a removal and an addition. So here, if we change the behavior of a function without changing its signature, and here all the parameters are remaining the same, the return times are remaining the same, then if the name remains the same, the linker could select a new implementation when it's statically linking stuff together, and yet link in previously compiled code that was expecting the old semantics. And if that happens, then we could have an ABI mismatch, even though like the structs being passed or the classes being passed are still the same size. It's the interpretation of behavior and the expectation that's changing. But if we rename a function, then the old code looking for the old name will never accidentally pick up the new name. And any other functions that are being compiled newly will only look for the new name. So everybody will agree on the behavior that they're getting. And the final binary might contain both the old and new implementations, but that's okay because they have different names. I think the issue that you found is that in this case, because we're doing this sort of header-only rename,
Yeah.
we should not provide an implementation of the old name that calls the new name, that actually directly undoes the purpose of the rename. I believe that if you search in this branch for all occurrences of the old name, I would expect that there are none except for this old definition. And I think that this definition, the lines 6586 through 6590, should be removed, so that the new code base will only have the new name and any occurrences the old name are provided, so that just in case there's some difference in interpretation where old code was really expecting SystemClock now to be called, we never have a competing implementation under the old name. I think Statement Reply was imitating a technique we use elsewhere, but that technique is specific to separately compiled code. In separately compiled code, we can't ever especially remove, but also rename exported functions, because that would break the DLL exports. And in that case, we will provide the old or an old named function, possibly adapting its behavior under a new implementation for ABI compatibility. But that's very specific to it being separately compiled. But this code here is an STL Inc. chrono. And because it's header only, we should be doing the header only rename technique. And it's very it's totally reasonable for this confusion to happen, because we don't comment why we're doing like the V2 in like excruciating detail, because the ABI concerns are so complicated to convey in a few sentences.
Yeah. Okay, cool. I'm gonna actually open up the other files that are being changed and just kind of see to xtimeh 10-day. Yeah, I'm curious to see. Actually, what's in here? Oh, it's just continuation of it. Okay, cool. Yeah, it looks like these in condition variable are being renamed, or calling v2 instead. Same in mutex. More in mutex. Thread. Okay. All right, that seems correct. I guess another step could be actually searching through like the existing header or headers to see if there are any other calls. But I think that we have at least enough here to at least mention, hey, we think this might not be right. Can you tell us if you disagree and why? All right, now I have to try and explain ABI things that I just learned in a comment. Okay. Do you have something that I'm trying to do with reviewing is not only like say what should be fixed or why it's wrong, but also like here's a reference for an example to look at, like a similar kind of structure. Do you have one in mind, Stefan, that would be good to point to? The only one that I can think of off the top of my head that I've seen recently is the orphan.me unlocked v2 from the const.expr stuff.
Yeah, I think the orphan v2, the orphan.me v2 is the most recent example of a function only rename. The other ones that I'm familiar with have all been struct renames, where we've got like ref count obj alloc v3, or ref count obj alloc 3. I think we didn't put a v in there. There's also a few, I think there actually are a few function renames in the concurrency, the parallel algorithm stuff. If you do a regex search in the branch for ugly name ending in a digit, I think that will actually find a few of them. The digit would be 2. I think there's like a couple that are 3, but they're always low numbers because we haven't had to revise them and place that often.
I thought that iterator base 1.2 was like you had to make 11 versions of this before. Didn't quite 1.2 separately.
Yeah, that one is a different example. I might be able to find them too. I can do a search.
Okay, thank you. I will for now try to explain in at least somewhat reasonable terms what's going on here, and then I can also leave a note to like come back and add a reference or a note of where to look for an example before I actually post review. Okay. The v2 version of this function is great. However, I think that we actually should remove the newly defined, well, old named function, which calls the v2 version. We follow this type of pattern when we are dealing with v2 versions in, I think you said it was separately compiled code, or
the add remove, that is for header only.
yeah.
It's the separately compiled code that must continue to provide the old name with ideally the old behavior.
However, in headers, we follow an add remove pattern. You can see examples of this.
I think one example is in execution. If you look for static partitioned find, actually, let me get the name again. Oh, look for in execution static partitioned stable sort 3. That's the highest number I can find.
I don't think we should be trying to go above that.
Yeah. Oh, this is a struct, but it still demonstrates the same principle that you're not going to find a classic or a 2 there. You'll only see the 3.
I will link to the beginning line for the struct declaration. Don't click the Teams thing.
Yeah, we're most concerned about renaming the structs because their data members change, and so if a single instantiation sneaks in, super duper badness. It's the functions that occur much less often because almost always the behavior changes are paired with signature changes. And so there we just keep the name because the mangled name is changing, but like with the orphan me v2, that was a rare case where the signature did not change.
Yeah, locking things.
I can find a file for that too while you're right there.
It's probably an X utility, X string, or vector. That's all. That's where all the context for stuff was. And can I link a code thing? Ooh, I like it.
I think if you, instead of hyperlinking it, just include the URL, you'll get the cool little preview.
Right.
Yeah, it'll disrupt the flow of your sentence a little bit more, but you'll be able to actually see the code.
That's okay. Let me know when you, don't click it. Sorry.
V2, the V2 is actually in X memory.
Oh, just had to make me wrong. Okay, X memory, orphan. I think it was unlocked, or orphan me V2. It must have been this one. Permalink. Thank you. So quick. Actually showing up. All right, not bad. Cool. Notice in each of these cases, you won't be able to find a v1 or original version of these function. You don't need to retain the old name. This is the part there that gets squinty for me. If the linker goes to look for the old name, it's not going to mistakenly find that old name with new behavior, which could cause problems. Instead, it just won't be able to find it, so we won't run into that scenario.
I think that's all correct, except that if their linker is looking for the old name, it would have been provided by one of the old object files.
Right, okay. If the linker goes looking for the old name, it won't mistakenly find a function with new behavior. It will use the definition in old, you said object files?
That's right.
Great, thank you. The original preceding versions are simply moved. We don't need to retain the old name. If the linker is looking for the old name, this is not a very good sentence. We don't need to retain the old name. In fact, we shouldn't. And we remove the old definition slash name entirely. If the linker goes looking for the old name, it won't mistakenly find a function with new behavior. It will use the definition in old object files. The removing old name will ensure we don't run into an ABI mismatch where we provide different behavior than is expected. Okay, this is a very long comment made longer by the code snippets. We follow this type of pattern when we are dealing with v2 versions and separately compile the code, because in that case we are required to continue to provide the old name, ideally with the old behavior. However, in headers we follow an add remove pattern. You can see examples of this here and here. Notice that in each of these cases you won't be able to find a v1 or original version of the struct/function. The original/preceding versions are simply removed. We don't need to retain the old name. In fact, we shouldn't. When we remove the old definition name entirely, if the linker goes looking for the old name, it won't mistakenly find a function with new behavior. It will use the definition in old object files. Removing the old name will ensure that we don't run into an ABI mismatch where we provide different behavior than is expected. Okay, I think this seems reasonable. Hopefully, statement reply knows to feel free to follow up if anything is unclear there. I guess I will also note. This is not really, I was thinking maybe just add like, obviously we're not calling it anywhere, so it seems like this is purely retained for concern over ABI things, but it turns out to be unneeded. But I think statement reply is aware of that. Okay, cool. All right, hey, look, we got through a whole file and it's 5:28. I guess technically we got through 2 files because we got through the CMake lists too. I can actually go through maybe in the last 2 minutes some of these other ones because they are very quick. Just calling the v2 versions here and here. Good things to do, actually. Good things to do normally, I think, would be to actually go and search through the various header files and see if there are any other calls to 2xtime 10-day clamped that are not being changed here. But if statement apply goes and actually removes that function, the compiler will do that work for us. So we love when that happens. These are also just changing to the v2 versions. That's great. Another one in thread. And let's go ahead and just skip over the more substantial pieces just because we don't really have time at the moment. But in the last minute or so that we have, are there any questions that I can attempt to answer?
I didn't see any questions in the chat. I did mention that as you were looking at like those comments, I was reminded that we actually did have a typo in epic adjustment long ago. So centralizing that is definitely worthwhile.
Wow, that is, I mean, it seems very understandable because it was very unintuitive what that big long hex string is. But yeah, if we have a good place for it now, that's great. I'm glad that I was able to actually teach Cameron some things about time. Whenever you're looking at chrono code, there are so many puns to be had. So hopefully people comment on the video with some good ones. All right, I'm gonna go ahead and wrap up this code review. I will maybe submit a partial review just to kind of let Statement Reply know, hey, we're looking at this. I know it's been a while. And then come back and look a little bit more in depth at the xtimeh 0 CPP and header files. And I think the test is really all that we have left. So still pretty good progress, I would say. Thanks everybody for tuning in. And I will go ahead and stop the recording and transcription now.